So these problems, we want to think of it as much like normal division as we can. So when I think about a normal division problem, if I had 72 divided by, say, divided by 9, what I'm looking for is how many times 9 goes into 72. And that's 8 times. So that 8 goes there. And then to find out if there's any more I can do, 8 times 9 is 72. Okay, so I take 8 times 9 equals 72, and I subtract that. In this case, I would get a 0. But sometimes there is a remainder. Like if I had 15 divided by 4. Well, 4 doesn't go into 15 directly, and so I just have to divide it 3 times. And 3 times 4 is 12 with a remainder of 3. Because this number right here is smaller than this number, I know I'm done. So the answer would be 3 3/4. Okay. The remainder of 3 over that original number. So that would be my answer there. The same idea is going to happen. I'm going to have some values, and then I'm going to have a remainder divided by the original number of 4. So that's how we're going to approach this, is trying to keep that as much the same as we can. The unique thing with these is that there are a lot of numbers and letters in here, but hopefully we can simplify it to as close to that as we can. All right, so as you see here, it starts off focusing on the leading terms. Okay. So really what you're looking for is how many times does negative 4x squared go into negative 16x cubed? And that can be hard because there's letters and everything else in there. So we actually do the division here. And just in case this helps explain it better, I've got 3x's on top divided by 2x's on bottom. So as I divide these, 2 of these cancel out. 2 of the x's. So I'm left with an x, and then negative 16 divided by negative 4 is a positive 4. So I'm left with 4x when I divide that. And that's the number that goes on top here. That's where you see this right here. That's where that comes from. Again, the unique thing is that you just focus on the first parts when you're dividing. First parts when dividing. Now, to figure out what you're supposed to subtract. The same way on the other one, where we were dividing 4 into 15, and we found that it goes in 3 times. We took 3 times 4 equals 12. And that's what I subtracted to find my remainder. So using that same idea, I'm going to take 4x times this to get this. And 4x times negative 4x squared plus 3. When I distribute that, 4x times negative 4x squared is negative 16x cubed. And just as a heads up, that should always equal that first number, because that's where we got it from, is by dividing. And so now we're just doing the opposite of multiplying. So that should always equal that. Now 4x times 3 would be a positive 12x. And you'll notice they lined up with the variable that has the same exponent, because that we're now combining like terms is really what we're doing. And so as I do this, make sure that whatever exponent is on the variable, you line it up with that same one here. So because these are x's, that's where it goes. So now I subtract. These cancel out. 4x squared, there is no other x squared. And then 13x x, 13x plus 12x is, I'm sorry, 13x minus 12x is equal to 1x. Then there are no other numbers, so the 6 just stays there. So now I have this right here. And I'll do the same thing I did up here, where I divide the leading terms. So I take 4x squared divided by negative 4x squared. So 4x squared is 4 times x, and negative 4x squared. So the x squareds cancel each other out, 2 x's, and 4 divided by negative 4 is negative 1. And that's where this number comes from. Once again, I'll take this number times that, and it will equal this line right here. So negative 1 times negative 4x squared plus 3, if I can draw a 3, and I distribute. And once again, the first term matches what I had before. And then negative 1 times 3 is minus 3. Now you'll notice there is no other just x here, and so there's nothing written there. The minus 3 goes with the positive 6. Those are like terms. And as we subtract, those cancel out. Positive 6 minus negative 3 is a plus 9. Now the same way we find out what the remainder is, how do we know this is the remainder? How do we know not to divide again? Well, it goes back to the idea of when we did 4n to 15. 4 is bigger than 3. So we stopped. We knew that this was a remainder. Same idea, but just dealing with exponents. This exponent is bigger than this exponent, and so we stop. Same idea. So it's not, we say this one's bigger, this one is bigger than this one. We're talking about exponents now when we do this type of division. Here we just look at the numbers, and that's a little more obvious. Okay, when this number is bigger than this number, we stop. When this exponent is bigger than this exponent, we stop. In the same way we wrote this answer as 3. Okay, that is where that 3 came from. That is where that 3 came from. So this is 3 3/4, and this is where the 4 came from. So whatever's up here is your number. So the 4x minus 1 is what we write first. Then whatever the remainder is divided by the original number. So the remainder was, oops. If I can do this. The remainder was x plus 9, and the original was negative 4x squared plus 3. So it follows the same pattern as what we had right here as far as where the numbers come from. This is your first answer. This is the remainder divided by the original.